Hello and welcome to today's webinar about gate solutions for hybridization. My name is Jason Ford. Okay, so during the session today, we'll be discussing emissions, powertrain trends, why the reason for electrification, hybridization and electrification, stop-start and mild hybrid, and also further gates hybrid solutions, what other parts and components gates supply and manufacture for hybrid vehicles. Okay, so emissions are just a general introduction to emission legislations, light duty vehicles. Basically, pollutant emissions are harmful to human health and affect local air quality. So basically, they affect the air that we all breathe. Pollutant emissions from automobiles equipped with internal combustion engines include what we call CO, carbon monoxide, which is colourless and odourless. It prevents transportation of oxygen in our bloodstream. We have HC, hydrocarbons, which are basically unburnt fuel particles, and scientific studies have linked some of these unburnt fuel particles as being carcinogenic. They are linked to forming cancer. We also have NOx, or nitrogen oxides, which give heart and lung problems, asthma, bronchitis, and also what we call PM, or particle matter. Now, this is the carbon or the soot and ash particles which are produced from the combustion process. And these all relate to thrombosis and lung cancer also. So these emissions are regulated globally by country-specific legislations. These country-specific legislations limit the maximum emissions allowed for each vehicle to be sold. Each new country-specific vehicle sold, large or small, must conform to the specific country emission legislations to achieve certification for sale within that country. So the reason for implementing these emission legislations is to implement cleaner air quality, so better quality of air for us all to breathe. Okay, so the first automobile emission standards were introduced in the USA, United States of America, during 1963. However, the first catalytic converters installed in the USA vehicles took place around about 1975 for petrol vehicles. This was a requirement by what they called the EPA, which was the Environmental Protection Agency for new exhaust emission regulations. In 1984-85, the first catalytic vehicles were introduced in certain European markets, such as Germany. The European emission regulations were introduced later in 1990s. So Euro Regulation 1 was around about 1992 introduced, which we saw electronic single point fuel injection systems, catalytic converters, all to help achieve the EU1 regulation. The European 2 regulation appeared in 1996. So for petrol vehicles, multi-point injection systems, so improved fuel mixtures to help the emissions that have been burnt. And for diesel, use of EGR valves and first direct injection systems were introduced. Euro 3 regulation started in 2000, so for petrol engines, it meant electronic throttle were introduced, which allows better management of the fuel to be injected. In diesel engines, we saw the introduction of high-pressure diesel common rail injection systems and also turbochargers. For hybrid applications, the new introduction of the Toyota Prius was one of the first hybrid vehicles in mass production, and Euro 4 legislation was introduced in 2005 So for petrol engines, we saw sequential injection, and the catalyst or the catalytic converter was located closer to the exhaust manifold. By doing this, it enabled quicker warm-up periods. So the catalytic reaction started quicker, meaning that the emissions were reduced quicker also. Hybrid applications, we saw stop and start systems become more popular, and the first gates micro-V EMD or electromechanical drive belts were introduced. Okay, so another Euro regulation, Euro 5, was introduced in 2009, which we saw a lot more what we call downsizing, smaller engines being used in vehicles to all aid with the emissions regulations. So for petrol vehicles, we saw direct fuel injection, catalysts located close to the exhaust manifold, as I've said previous, quicker warm-up. In diesel applications, we saw diesel particulate filters or DPFs introduced to control particle matter or the subparticles. And for hybrid applications, well, hybridization became more popular in 2009. Euro 6 regulation was introduced in 2014. For petrol engines, we saw petrol engines installed in vehicles and with a turbocharger. So we got more power from smaller engines. In some cases, we might have had twin turbos installed on a petrol engine for peak performance. And diesel engines saw the introduction of AD Blue systems or injection dosing systems, which help with reducing NOx or nitrous oxides. Also, for the diesel applications, we saw the introduction of 3-cylinder diesel engines also. Hybrids, we saw the introduction of plug-in hybrid vehicles, and then going on to what we call EU6D, European Regulation 6D, appeared in 2020. Mild hybrid technology becomes more popular between petrol and diesel engines using this kind of hybridization, all to enable to meet the stricter emission legislation being introduced. Now, these emission legislation have also had to go through severe testing. The vehicles that are produced have to go through severe testing to ensure they comply with what used to be NEDC or New European Driving Cycle testing procedures, which were introduced around about the 1980s. There have been complaints in the marketplace, though, that the test procedure was out of date, and the most recent update was around about 1997, which was well before hybrid vehicles and stop-start technology was generally available. It was recognised that the NEDC test procedure does not provide CO2 emission data for real driving scenarios. So this led to the EU Commission using what's known as the WLTP, or the Worldwide Harmonised Light Vehicle Test Procedure. The LWTP test procedure replaced the NEC test procedure for establishing the official fuel consumption and CO2 emissions of new cars in September 2017. This became mandatory for all new cars powered by an internal combustion engine by September 2018. And then all new light commercial vehicles became mandatory in September 2019. So, as suggested previously, the WLTP vehicle test procedures were introduced, started with passenger cars from September 2017, and light commercial vehicles started from September 2019. The WLTP is a more rigorous and longer test. So CO2 and fuel consumption have increased with the newer WLTP testing. Example, we can see here from the first chart on the left-hand side, the NEDC test procedure was 5.1 litres of fuel consumption for every 100 kilometres or 62 miles travelled. The WLTP, we're using between 5 and 8.5 litres of fuel consumed for every 100 kilometres to 62 miles travelled. So the table on the right shows it was the WLTP test is a more rigorous test. We can see the distances have become longer. The stop time or the engine oil time has been reduced so that we're getting more test results from a running engine. The average speed and the maximum speed have been increased. And also one of the big things was with the NEDC test, equipment such as air conditioning wasn't turned on because that meant it led to better fuel efficiency results. With the WLTP testing, if the vehicle is fitted with air conditioning, which most newer vehicles are these days, then the air conditioning would be turned on for a more realistic fuel efficiency results. And also any other special equipment that may be fitted to the vehicle may also be turned on as well to ensure that these results are more realistic. Okay, so the vehicle usage has been changing over the years. So urban driving, we're doing around about 20 kilometres or 12 miles a day. Middle distance drive is between 20 to 60 kilometres, so 12 to 37 miles a day. Long distance driving, which is more than 60 kilometres or more than 37 miles a day, which has meant that a lot of the average speeds now are between 6 kilometres and 30 kilometres an hour. So around about 4 to 18 miles per hour. So all this is due to such things as rush hour congestion, stopping at traffic lights, stuck in traffic jams, led to around about 15 to 30% of engine idle time. So basically, engine idle time is where the vehicle is stationary and not moving. So these implications have led to the implementation of the stop and start systems being introduced more and more into vehicles. Obviously, with stop and start systems, they offer better fuel efficiency, reduction in the amount of fuel burnt, and reduction in CO2 and exhaust emissions. Okay, so powertrain trends and why the electrification. Okay, so the automotive world is evolving faster than ever. Growing awareness of vehicle emissions has led to the implementation of more stringent emission regulations, as discussed previous. The OEMs manufacturers have manufactured more hybrid and all-electric vehicles to meet these stringent emission regulations. So the transition to hybrid and all-electric vehicles introduces additional and more complex cooling requirements. Mechanical drive systems are being replaced with electrical driven systems with higher power outputs and more compact powertrain systems. Product performance requirements and demands continue to increase as industry and OEM strategies are implemented to meet these evolving standards. So Gates is launching new products and services to meet these requirements. So again, why electrification compared to an internal combustion engine, or also known as an ICE? With an electric motor is more efficient than internal combustion engine. An electric motor uses 90 to 95% of the supplied from the battery for movement of the vehicle, compared to a petrol a petrol engine uses 25% of the power produced from burning fossil fuel for movement of the vehicle, and compared to a diesel engine uses around about 30% of the power produced from burning the fossil fuel for movement of the vehicle. So the electric motor far more efficient with the power that's applied to it and used compared to an actual combustion engine. Okay, so the OEM vehicle manufacturers use different types of what we call architecture for different hybridization vehicles. We have what's known as PO, where the electric motor is connected with the internal combustion engine belt on the front end accessory drive belt system, also known as the ABDS. We have P1 architecture, where the electric motor is connected directly with the crankshaft of the internal combustion engine, so no belts included. We can also have P2 architecture, where the electric motor is either fitted side mounted via a belt or integrated between the internal combustion engine and the transmission. P3 architecture, where the electric motor is connected via a gear mesh assembly with the transmission. And we also have P4 architecture, where the electric motor is connected through a gear mesh assembly located on the rear axle of the vehicle. Now, there can be advantages and disadvantages with all systems. Obviously, the advantages with these type of systems is all these systems offer better fuel efficiency and reduce CO2 emissions. The disadvantages for some of the more complex systems, and if we start talking about all electric vehicles, are where some of the systems are cheaper to manufacture than others. So with the all electric vehicles, especially the larger battery packs and electric motors, the size increases, so the manufacturing costs also increase with that also. So the OEM vehicle manufacturers will utilize the correct hybrid architecture to ensure the best value and efficiency across their vehicle range. And now just a little bit about the different levels of HEV vehicles or hybridization vehicles. So with the micro HEV or micro hybrid electric vehicle, we have an integrated alternator or starter unit known as a BSG that uses stop and start technology. The stop start technology shuts down the engine and restarts when the brake pedal is released normally. It's powered by the internal combustion engine when cruising. 10% fuel efficiency increase compared to non-hybrid vehicles. So with having the micro HEV, we have a 10% fuel efficiency compared to a non-hybrid vehicle. And just some examples of micro hybrids on the road today, as you can see, BMW 1 and 3 Series, Fiat 500, Smart Car, Peugeot and CS3, Ford Focus, Mercedes-Benz. And going into the mild HEV or mild hybrid electric vehicle, it's similar to the micro HEV, but we have upgraded and integrated alternator starter unit, or the BSG, belt starter generator, to assist in vehicle propulsion. With the micro hybrid, the BSG doesn't help with propulsion or movement of the vehicle. It's just literally for the stop and start purposes. So the mild hybrid electric vehicle uses the alternator starter or the BSG, belt starter generator, to also assist in vehicle propulsion or movement. So compared to the micro HEV, we have a larger electric motor. The alternator and battery pack play a bigger role during the vehicle operation. And we get around about 20 to 25% fuel efficiency increase compared to a non-hybrid vehicle. So as we can see, micro to mild, we get more fuel efficiency as we go into the different technologies. Micro being the basic model, obviously mild is round about mid-range. Now, as you can see, again, mild hybrids on the road. Some examples: BMW 7, active hybrid, Buick, more American sort of application, Chevrolet Malibu, Honda Civic, Honda Insight Hybrid, Mercedes-Benz S400 Blue Hybrid. And going into the HEV or full hybrid electric vehicle, again, similar to the mild HEV, uses the same electrical components, but on a larger size. And we have the electric only mode. So it's optimized efficiency thanks to a sophisticated control system. We have a battery that's around about 200 to 300 volts, and an electric motor is around about 30 to 50 kilowatts. All this architecture together offers around about 40 to 45% fuel efficiency, so it's an increase compared to a non-hybrid vehicle, and obviously more of an increase, fuel efficiency increase compared to the mild or the micro hybrid. So some examples of full hybrids on the road today. We have Chevrolet Tahoe hybrid, Toyota Prius Camry, Ford C-Max, Honda CRZ, and Kia Optima hybrid. Okay, so we also have what's known as a plug-in hybrid or a PHEV. So plug-in means you literally need to plug the vehicle into a charging point to charge its battery. So it's the same configuration as a full HEV, downsized engine and larger electrical components such as motor, alternator, battery pack. Capable of charging from a mains electric supply via a plug. So you can charge these vehicles on the driveway or in the garage at home, as long as you have a safe environment to do so. The fuel efficiency is similar to a full HEV while the internal combustion engine is operating. And this is ideal for urban commuting and short trips. So some examples of plug-in hybrids on the road today: Chevy Volt, Ford C-Max, Porsche Panamera, Toyota Prius, and Volvo XC60. The BEV type of hybrid or battery electrical vehicle is not actually a hybrid, but it's an electric vehicle powered only by the battery. There is no internal combustion engine, so there's no backup if the battery fully discharges, but this is ideal for urban commuting and short trips. Some of the BEVs on the road today, all Tesla models: Peugeot E208, Hyundai Kona Electric, Mini Electric, MG ZS EV, electric vehicle, Nissan Leaf, Renault Zoe, and the Kia Niro. Okay, so in 2020, the internal combustion engine is around about 84% of the market. The hybrid plug-in electric vehicle makes up about 9% of the market of sales. And the mild hybrid with stop and start technology is around about 7%. As we start increasing sort of in 5-year increments, then we see in 2025, the internal combustion engine is now only going to be around about 55% of the market. Mild hybrid and start vehicles will be around about 23%, and hybrid plug-in electric vehicles will be around about 22% of the market. So as we can see, as the years go on, then more of the electrification or hybridization vehicles are going to be replacing internal combustion engine vehicles. So by 2030, we can see a hybrid plug-in electric vehicle will be around about 40%. Mild hybrid start will be about 34% of the market, and the internal combustion engine will be down to about 26% of the market. So you can see in a 10-year time slot, then the internal combustion engine is slowly starting to be phased out. Okay, so now stop and start mild hybrid. So powertrain trends in stop and start technology require high strength drive belts, such as Gates E-Start belts. So the highest strength drive belts are required to carry the high loads of engine startup and highly engineered bi-directional tensioners, which we'll see shortly. Okay, so some differences within the systems. We can see a microhybrid generally runs on a 12-volt system, whereas a mild hybrid operates with a 48 or up to a 48-volt system. Now, the differences being the electric motor in a micro hybrid or the BSG, the power rating is round about 2 to 3 kilowatts, which is required to start the internal combustion engine. With a mild hybrid, the BSG power rating is around about 10 to 15 kilowatts. Now, the power rating's difference is due to the mild hybrid's BSG operates together with the internal combustion engine to move the vehicle forward. So therefore, higher power rating is required for the BSG motor on the mild hybrid. The micro hybrid vehicles only use the BSG or the belt starter generator to start the actual engine. It's not used for propelling or moving the vehicle forward in the micro hybrid. So the micro hybrid BSG in generator mode or alternator charging mode takes about 3 kilowatts. With the mild hybrid in generator mode, the BSG in generator mode, the charging mode is around 10 to 15 kilowatts. The EV mode range or electric vehicle mode only, so how many kilometers or miles can a micro hybrid or a mild hybrid vehicle travel with just the electric motor? Now, in both cases, with both micro hybrid and mild hybrid vehicles, it is not possible to travel with only the BSG motor, as these are always connected to the engine, normally via the crankshaft, via a belt. So this is why we see the EV mode range is 0 for micro hybrid and mild hybrid. Now, the CO estimated benefits for a micro hybrid around about 5 to 7% reduction in CO2, and for a mild hybrid is around 7 to 12% reduction in CO2, obviously compared to an internal combustion engine only. So there are benefits. If we obviously it might not seem a lot for one specific vehicle, but then if we time the thousands, millions of vehicles on the roads globally, then it is a huge reduction in CO2 emissions being emitted from tailpipes. Okay, so the micro hybrid system components. So a micro hybrid can either incorporate a starter motor and a normal sort of alternator with no BSG, so no belt starter generator, or system can incorporate a starter motor and a BSG or belt starter generator system. On these systems is required for the initial cold start of the engine. Once the engine's warmed up, then the BSG will take over after a certain temperature, the starting of the engine. So there are also other components in the system, such as obviously batteries, battery stabilizer, what's known as car sensors, belts, tensioners, and electric water pumps. So if we look at the table data on the left, the BSG type system with the starter motor and a BSG emits 7% less CO2 compared to an engine without a BSG. So a starter motor and normal alternator system, so no BSG in the system, emits 5% less CO2 compared to an engine without. So obviously the BSG system offers another 2% approximately, because on the stop and start cycles compared to a system that is relying on the starter motor for all the stop and start cycles. Now, the batteries required for these stop and start systems are different to what we know as the old lead acid type batteries. Now, we have two types of batteries, what's called the EFB, which is an enhanced flooded battery, and an AGM absorbed glass material type battery. So the EFB is an improved lead acid battery. It has less internal resistance, and the newer material doubles the charge cycles rate that the battery is capable of. Now, the charge cycle rates are important characteristics of a battery installed in a stop and start system environment. So this enables a higher load capacity in comparison with a standard lead acid battery. The AGM, or absorbed glass material type battery, is totally maintenance free and leak proof. It's very good. It offers very good cold start capability, and it also enables a warm engine to be switched off and started again several times within short interval periods. It is a very good battery choice for a stop and start systems that incorporate the regenerative braking energy. So during startup, voltage in the system drops. Therefore, these type of vehicles need to stabilize the system voltage. And basically, this is done in two main ways. It can either be using what we call a DC-DC converter or an accumulator or ultra capacitor. So the DC to DC converter is used in engines installed with a starter motor and no BSG. So when the system voltage drops, the converter ensures the correct working voltage is maintained. And there was an evolution in this kind of voltage stabilizer, and today the converter is used to maintain the voltage for the main electrical system. Looking at the accumulator or the ultra capacitor, now either one or the other will be installed dependent on the vehicle manufacturer and the system that's being used. They're usually installed in engines with a BSG to restart the engine. Now, with the accumulator, it's a small auxiliary battery used to restart the engine via an internal control unit, and this ensures the correct system voltage is maintained. An ultra capacitor or a supercapacitor is charged during the driving cycles and helps the BSG to restart the engine. Now, we need to be aware special steps are required to disconnect or change when we're changing the battery if the car has an ultra capacitor. There are certain safety steps that have to be followed so no accidents take place. Okay, so these systems work with various sensors, engine sensors. So to enable a quick restart, the system needs to know the position of the crankshaft. So crankshaft position enables the system to calculate when and where to inject the fuel mixture. So basically the correct engine chamber the mixture needs to be injected into. This then enables a quick start. Engine temperature sensors are used, obviously checks if the engine is at normal operating temperature. And other car sensors, such as vacuum pressure in the braking system. So the braking system is classed as a security system. So to ensure braking efficiency, the engine will not stop if insufficient vacuum is maintained within the system. Now, position brake pedal is released, then the engine will start. The stop and start current vehicles generally have the option for the driver to activate or deactivate the stop and system. If the system has been deactivated, then obviously the system will not operate as a stop and start system until it's been reactivated. With climate control, so if air conditioning is turned on and the climate conditions haven't been met, then the engine will not stop. If cabin heat is required inside the vehicle, again, the engine will not stop. Battery sensors also monitor the state of the battery, so how much charge is being received from the alternator, 70, 80, 90%, etc. And it checks the internal resistance and temperature to ensure that the batteries, if the battery's too hot, then reduce the charge rate from the alternator. So it's all safety related. Battery replacement, we need to be aware some vehicles require the electric control unit or the ECU to be reprogrammed with the new battery information whenever a new battery is installed. If the ECU is not reprogrammed with the new battery information, then the vehicle and the start and start system will not function correctly. Okay, so the stop-start belts used within the system. And previously, higher strength drive belts are required to carry the high loads of engine startup and highly engineered bi-directional tensioners. Due to short drive belt entry spans, sort of into the BSG, the BSG pulley increases. So the entry span to the pulley of the BSG unit increases, the difficulty to maintain a low belt entry angle, which enhances the system tensioning and traction. As we can see here, the entry angle, BSG unit, we need a tighter angle to ensure the tensioning and traction is maintained. The dual arrangements have shorter belt spans, so meaning smaller wrap angles around the system's pulleys, especially the BSG and the tensioner pulleys. So shorter belt spans and smaller pulley wrap angles lead to temperature increases and alignment issues within the system. So the belts can generally tend to run hotter, hence why we need the higher strength belts within these systems. So Gates Sidewinder tension arrangements, which we'll see later, have been designed to enhance stop and start system environments. And they also enable low belt entry angle and belt spans, which also leads to reduced alignment issues. So shorter belt spans and smaller pulley wrap angles require stronger drive belts, as we've said all the way along. So the Gates E-Start micro belts are manufactured from EPDM rubber, which is loaded with fibres. Now this offers rib flexibility and strength. We also have aramid tensile cords, which are used for longitudinal strength and stability throughout the belt. The special adhesion rubber is used to bond the belt and also contributes to belt stability. Now, backing fabric is used and it's due to enhance system tensioning requirements within the stop and start system environments. So because of the higher tensions that are required, obviously the back of the belt and certain pulleys, which is due to the used within the tensioning system. So we require a backing fabric to give extra strength to the back of the belt also. So we need to ensure that Gates E-Start belts are installed to stop and start applications. The standard belt construction, as we can see from the picture, will not withstand the higher tension and traction requirements of these type of systems. The E-Start belt construction the Gates E-Start belts are manufactured to withstand the higher tension and traction requirements of these systems. Stop and start systems can generate 2 to 4 times more tension and 1.5 to 4 times more traction compared to a non-stop and start type system. The micro V belt selection is critical to ensure premature belt and system failure does not occur. Okay, so now the stop and start tensioners within the system. Okay, we have a couple of examples of what we call single tensioner systems. You can see the first one on the left, 6PK 803ST, is used on Smart Car, the 4.2. It's a 1 litre petrol, 2007 model year. The 6PK 1029 EST, Citroen C3 1.4 petrol model, 2004. and the 6PK 198 6EST Mercedes A150 and B150 Blue Efficiency 2005 model year onwards. Now, these systems that these belts are incorporated with, the BSG systems that they incorporate with, use an accumulator, as we discussed previously, to help with maintaining the battery start and stopping and system voltage, etc. So these applications are a selection of what we call the first generation vehicles installed with the BSG, or belt starter generator technology. So smaller engine and lower tension systems. The tension in these sort of systems would be up to around about 35 Newton meters of tension with a single tensioners. Now, some versions of these applications also had other stop and start systems installed without BSG technology. These systems relied on the starter motor for start and stop system functions. Now, these systems do not have an OAP, or overrunning alternator pulley, or OAD, overrunning alternator decoupler pulley, installed within the system. Okay, so now from a tensioner aspect, we can see these are what we call dual tensioner systems. So these type systems incorporate two tensioners rather than a single tensioner. Now, as things have progressed, it's realised that obviously the belt traction and the tensioning requires more tension to enable good start-stop functions. Now, these BSG systems that are included, that these belts are fitted to, the system incorporates an ultra capacitor, and the applications are a selection of what we class as second generation vehicles installed with BSG technology. So again, these sort of systems will be, these belts, the 6PK numbers will be fitted to various Citroën Peugeot applications. And when we look at the 6PK 1073 EST, it's various Citroën Peugeot, Toyota and Vauxhall applications. Now, these second generation vehicles installed with BSG technology, again, we have smaller engine but higher tension systems, and now the tension on these systems using the dual tensioners can be up to 70 Newton meters. So obviously, because two tensioners, it's double the amount of tension within the system also. And again, some versions of these applications also had other stop-start systems installed, which was without the BSG technology. Again, these systems relied on the starter motor for the stop and start system functionality. Now, here we have a selection of micro hybrid applications installed with Gates OE components. This selection of applications from Citroën, Peugeot, DS, Toyota, Vauxhall, Mercedes and Smart may be installed with or without BSG technology, and it may be installed with either single or dual tensioner systems, as we've discussed previous. These products are also available from Gates aftermarket replacement range and branded as Gates eStart range or eStart products. Products within this range are defined by EST at the end of the part number. So EST is for eStart, and all part numbers shown on this page are available as Gates eStart Micro V belts or as eStart Micro V kit type formats. Okay, mild hybrid technology. So why mild hybrid technology? So if we take a 100 horsepower internal combustion engine, which can consume approximately 5 litres of fuel every 100 kilometres or 62 miles travelled, it produces around about 140 grams of CO2 emissions. By downsizing the internal combustion engine to approximately 80 horsepower and then adding a 15 horsepower or 20 horsepower electric motor, it will equal horsepower internal combustion engine plus 20 horsepower electrical motor, which gives us the same 100 horsepower output of the larger internal combustion engine. But this type of arrangement, with using a smaller downsized internal combustion engine and an electrical motor, then this type of arrangement consumes around about 4 litres of fuel every 100 kilometres or 62 miles travelled, but only produces around about 95 grams of CO2. So therefore, we've got less fuel consumption and less CO2 emissions by using a mild hybrid. So mild hybrid vehicles are the cheapest option to achieve lower emission requirements. Full hybrid vehicles are always a more expensive option compared to a mild hybrid vehicle. As we said previous, full hybrids, etc., electric motors, battery packs tend to be larger, so the prices increase with the architecture used. Okay, so with a mild hybrid sort of vehicle with an internal combustion engine and a BSG type system, there's around about 5 working modes: start, torque assist, cruise, energy recovery, and obviously the stop and start functionality. So when the vehicle starts, when the car starts to move, then the BSG system starts to operate along with the internal combustion engine, ensuring a smooth operation and gives the vehicle a bit of extra boost for initial movement and propulsion. Torque assist, so during acceleration or say driving up a hill, the BSG unit can provide assistance by drawing power from the battery to assist the internal combustion engine. The BSG, as we said, gives an extra push. In cruise mode, when driving at a constant speed, the combustion engine partially recharges the battery on the while the vehicle's on the go if the charge level is too low. Now, energy recovery, when decelerating or braking, the energy generated by the movement of the vehicle is converted by the BSG into electrical energy to recharge the battery. And then in stop and start, in the stop start mode, when decelerating to a stop, the combustion engine automatically shuts off during deceleration and braking to save fuel. Okay, so here we see mild hybrid architecture. So what are the components within the system? We have a work group, the belt, Sidewinder tensioner, and BSG. We have an air compressor, a lithium battery, a DC-DC converter, a 12-volt battery, and other components that can be within the system, an EWP or electric water pump, an E-turbo. Now, some of these newer models also incorporate electric turbos, and also electric power steering. So other components within the system, the lithium battery, generally around about 10 kilowatts, continuous discharging and charging power. Peak performance around about 20 kilowatts. The voltage ranges from roughly 28 to 54 volts. And these batteries are composed of several individual cells at 12 to 14. Now, an internal control unit manages the charge of each cell individually. And generally, these type of batteries do not need cooling requirements on the vehicle. The BSG, or the belt-driven starter generator, is slightly larger than a regular alternator. It's managed by its own control unit. There's a Hall sensor incorporated to establish the rotor speed. So the rotor speed of the BSG unit. And these systems are normally fitted with what is known as MOSFET transistors. MOSFET means metal oxide semiconductor field effect transistors. So the belt construction of an E-start belt, as we can see, we need higher strength drive belts as required to carry the high loads of engine startup and the highly engineered bi-directional tensioners. So The Gates E-Start micro V-belts are designed for the engines of tomorrow. The E-Start micro V-belts offer high load and flex design, capacity and durability for over 600,000 starts, and the rubber compound, special rubber compound rubber, coupled with the advanced adhesion technology, which molds everything together. So we also have enhanced aramid cord pack material. As we said previous, the cords give longitudinal strength to the belt, and it is of what's called a quiet construction for ultimate noise resistance in all conditions. So Gates E-Start micro V belts offer OE quality and reliability for all of your stop and start system installations. Now, earlier on in the presentation, we saw some single tensioners and some dual tensioner type systems. The latest type of tensioner is what's known as a Gates Sidewinder tensioner. Now, the basics are, as you can see in the diagram, the Sidewinder is installed onto the BSG unit, and Sidewinder, as the name sort of presents itself, you have a tensioner and a pulley on either side of the unit. So when we have acceleration or deceleration, braking, etc., then this unit will actually move from side to side, obviously, hence Sidewinder. Now, they can come in different formats. We can have a standard right, what we call standard right arm, standard left arm, or a standard flipped over arm. This is obviously all dependent on the vehicle manufacturer and the system that these units are being installed to. So the operation of the Sidewinder, in cruise mode, the crankshaft rotates clockwise, as most engines, internal combustion engines, the crank rotates clockwise. When it's in operation, we're pulling the belt from the right hand side, so therefore higher belt tension is on the right hand side. So the Sidewinder rotates anti-clockwise to apply tension to the lower tensioned left hand side and further reducing belt vibrations, obviously, within the system. In the boost mode or acceleration mode, both engine crankshaft and the BSG, the belt starter generator, are applying power to move the vehicle. So the Sidewinder adapts to the power inputs from both the internal combustion engine and the BSG, and belt tension is adjusted as required. So obviously you can see the Sidewinder can move clockwise and anti-clockwise. In start mode, the BSG applies the required tension to the belt, obviously during the startup procedure. From obviously the startup procedure from the belt starter generator or the BSG. Okay, so accessory belt drive systems are becoming increasingly complex. Such things as electrical USB ports, air conditioning, and power steering are just a few of the key comfort and safety critical systems by the modern accessory belt drive system. The belt, tensioner, and pulleys all work together as a system to provide the power required for these accessory systems. Any component failure will have a much higher impact on the performance of the entire system and the engine. An unexpected system failure can have serious consequences, such as overheating of the engine or the sudden loss of power steering at a crucial moment. As an original equipment supplier, Gates recommends that garage workshops replace all wear parts at the same time with high quality components. And Gates offers smart all-in-one solution kits supplied in one box. What are the advantages of installing Gates kits? So restoring the complete system with perfectly matched OE quality components prevents costly comebacks. You're only ordering one product, which saves time and money. Warranty covers parts within the kit, and a full range is available for more than 90% of all European vehicles. So Gates have actually come up with what we call the Gates kit calculator. Now you can go to gatestechzone.com and click on the kit calculator tab to give the kit calculator a try and see how you money by installing kits rather than installing individual parts. As we've said all the way along, Gates is an OE manufacturer and supplier to all major vehicle manufacturers. And here you can see a selection of OEM manufacturers: Mercedes, Volvo, Mazda and Ford. And these manufacturers install Gates micro V-belts within their mild hybrid vehicle applications range. So these products are now also available from Gates aftermarket replacement range and branded as Gates. As I said previous, products in this range are defined by EST at the end of the part number, EST relating to E-start. So we can see here we have a Mercedes application 6PK 1196 EST, Mercedes C-Class, CLS, E-Class, GLC models. Now, Mercedes mild hybrid range is also known as EQ Boost. Some manufacturers are not just calling, hybrid this, hybrid, mild hybrid, micro hybrid, etc. They're using specific brand names. In the likes of Mercedes, their mild hybrid range, as I said, is EQ Boost. 7PK 1190 EST, a Volvo application for S60s, V60, V90, XC40, XC60 and XC90 is Volvo mild hybrid, and their Volvo don't appear to be using any abbreviated acronyms. The 6PK 995 EST is fitted to Mazda 3. Mazda mild hybrid range is known as Mazda M hybrid, so virtually the same. And in the case of Ford, the new Puma there, Gates belt 6PK 1179 EST. Now, the Ford mild hybrid range is generally known as MHEV, or mild hybrid electric vehicle. So different manufacturers can be using different acronyms or abbreviations of their mild hybrid or micro hybrid, etc. ranges. Okay, so now some further Gates hybrid solutions. So the water pump, the impeller circulates, as we can see, the exploded view on the right side of the screen. The impeller circulates the engine's coolant, the electric motor transforms electricity in motion, and the control unit, or the PCB, controls the speed of the water pump. Now, some manufacturers use electric water pumps, main water pump. So mechanical water pump exists either an SBDS or ABDS system, or so a timing belt system or accessory drive belt system. If the main water pump is electric, then the main electric water pumps generally operates between around about 400 to 600 watts. Now, some examples of vehicle manufacturers that are using main electric water pumps, some BMW 1, 3, 5, 6, 7, X1, X3, X5 and Z4 series. Some Toyotas, Aris, Prius, Yaris applications are using the electric water pumps. Lexus CT, Mercedes AB, E, G, M, RV class and Mercedes Sprinter and Vito are using an electric water pump as the main water pump in the system. And most modern cooling systems will also contain either or contain other electric water pumps to cool various components, such as electric motors, batteries, battery packs, inverters for certain hybrid vehicles, and for turbocharger cooling also. So what benefits of using electric water pumps? Well, again, reduction of fuel consumption, therefore reduction in CO2 emissions. With a belt-driven mechanical pump, water pump usually uses around about 2 horsepower of constant engine consumption. So that leads to higher fuel consumption and higher CO2 emissions. So by using electric water pumps, we're reducing fuel consumption and higher CO2 emissions. Electric pump works on demand and is independent of any engine revolutions because it's not driven by a belt. It's purely by the battery supply, the voltage supply from the battery. And the electric water pumps can operate when the engine is switched off. So obviously things like turbochargers may still need cooling capability when the engine's turned off because the turbo can still be spinning. So to reduce damage to the turbo, coolant is still required to circulate the system. Electric water pumps may be manufactured as brushed, which is with brushes, or brushless without brushes. The newer brushless types are generally more quieter in operation than the brushed, than with brushes type options. Okay, some common electric water pump faults. We need to ensure no cracks, fractures around the plastic connections, no cracks, fractures around the pump bodies, and ensure no leaking coolant hoses around the working area of the electric water pump. We need to ensure the plug connections are tight and waterproof. And we can see on the middle picture, there's a cap here with a smoke trace from internal electronics overheating. So we can get foreign body ingress from failed sealing rings, gaskets, or loose wiring plug connections, and overheating from overworked pumps, which can be down to coolant system contamination. All this leads to pressure, impeller, and bearing failure. Now, we need to ensure when any work's carried out on the cooling system that the system is correctly flushed prior to the cooling system being refilled. If we don't flush the system and we have any forms of contamination, electric pump systems, because we're relying on the battery power for the circulation, the pumps aren't being driven by a belt any longer. And we need to ensure that the system is free and clean of any contamination. If we do get contamination, it can lead to the issues that we can see on the screen, especially for the overloading, etc. Now, some systems may actually incorporate some sort of a filter, as we can see here, to try to filter some of the contamination within the coolant. But generally, we need to ensure that the systems are flushed correctly prior to installation and refilling of the coolant. Okay, so Gates product range has solutions for various hybrid applications: mild hybrid, plug-in hybrid, hybrid, and serial hybrid, as you can see on the screen. So products within the Gates range, solutions that Gates have for various hybrid applications are such things as electric water pumps, synchronous belt drive components, or SBDS, timing belt system kits, micro V belts and kits, hot oil belts, or for belting oil systems such as oil pump drives, etc., air intake hoses, crankcase breather hoses, moulded heater hoses, thermostats and radiator caps. Okay, so please also note to ensure you get the right component or correct components for your car, you can visit www.gatesautocat.com, which is Gates cataloguing system, online cataloguing. And we also have www.gatestechzone.com for any technical related issues. You can visit for technical advice and help. Okay, thank you very much. Thank you for attending this webinar on hybridization solutions from Gates. We hope to see you in the future shortly. Thank you. Stay safe. Bye for now.